For question number 7, so you can see they say express these fraction as partial fractions. Okay, so but for this question they didn't guide us. How to split. How to split into the partial fractions. So all it depends on our knowledge about our partial fractions that we learned in Sem 1. Then after that, only we evaluate. So we find out the integration for this fraction. Okay, so we go for our concept of doing partial fractions. The first step is we're going to see whether this fraction proper or not. Okay, so we can see numerator quadratic, denominator is cubic. So denominator function is greater than numerator. So this fraction is proper. So degree of denominator is higher than the degree at numerator. So this fraction is proper. So that will be our first step. This is a proper fraction. Okay, then second step we're going to see the denominator. Second step we're going to see the denominator. Our divisor here is 2x cubed plus 3x. So we have to factorize it completely. So how do we factorize it completely? We can take out x. So it will become 2x squared plus 3. Okay, so this is very obvious. This is our factor x. And then this is our factor quadratic, where this is 2x squared plus 3. We cannot factorize anymore. So this is our second step. Then only we come to the step number 3, so that we can write this fraction into a partial fraction form. So we rewrite this fraction. Okay, so of course this denominator we will substitute by the factor form that we done just now. We are going to split our fraction into the partial form according to its factor. So we can see the denominator factor here, the factor of x. And then another factor is 2x squared plus 3. So this is linear factor. So this is our step number 4. This is our linear factor. So up here we will have a constant a. So when we have a quadratic factor, so denominator part will be a linear. So it will become bx plus c. So this is how we write our fraction in partial form. Okay, in partial form according to its factor. So factor linear, numerator constant. Factor quadratic, so numerator will be linear. Then after that, our next step we're going to form an equation. So we will equal their denominator. So we'll form an equation about our numerator here. So 8x squared, this is our complete fraction. This is our complete fraction. This is our partial fraction. So they should be equivalent to each other. So this a will be times with the factor that it don't have. You can see the factor here underneath is x. So the factor it don't have is 3x squared plus 3. So meanwhile, for this, remember to put in bracket because we have two terms here. Bx plus c, we have two terms here, so we have to put in bracket or you make us confused. So when we don't put in bracket, it will become bx plus c times x. Then we confuse only c times x. So we forget about our bx. So actually, this is the whole thing. So the whole thing, bx plus c times with the factor x. So put in bracket. So we managed to form an equation. So this equation is for us to find out what is our a, what is our b, and what is our c. So we have 3 unknown. So when we have 3 unknown, the case of 3 unknown, we will let 3 times. Okay, we will let our x 3 times to find out that unknown. So what is the value of x that we can find? We can use our roots. So we can see our roots here. So one of the roots is x equals to 0. So other roots we can't find, we can't get any roots. So we just find the x equals to 0 first. Okay, so the rest of it 2 unknown, we'll use comparison method. So let method only finding x equals to 0, find one of these unknown first. So we can combine two methods together. So we can use let method combined with comparison method. So this is let method combined with comparison method. So when x equals to 0, we substitute inside, we get 15. So here we get 3a. So this 0 times everything. So we managed to find one of these unknown first. So after that, we will use our comparison method. When we want to use our comparison method, we have to expand everything. So based on this equation, based on the equation that we already found, where we already know our A is 5. So the step of comparison now is finding our unknown B and C. Okay, so from here we're going to expand 10x squared. So expand it, then x squared, then plus 15 plus bx squared plus cx. So that you can see here our quadratic terms. Okay, our x squared coefficient here is 10 plus bx squared. For coefficient of x, it's just cx. For constant, this is 15. So it should be equivalent to the left hand side here. Then we can compare. So that's why this method is called comparison method. So we compare our left hand side and right hand side. You can see for x squared, the coefficient here should be 10 plus b. So this 10 plus b should be equal to 8. Okay, so coefficient of x squared, we compare with coefficient of x squared. So coefficient of x, we don't have any term x in left hand side. So means this c is 0. So you'll notice that our constant is same. Okay, so from the comparison method, our result, what can we get here is 8 will be equal to 10 plus b, this coefficient from x squared. C will equal to 0. So from here b, we can notice that this is getting negative 2. Okay, so this is how we use our lab method and comparison method together. So just now I didn't let here 2 times because I didn't have any roots from our factor anymore, because we have 2. When we have 2, random value will be more difficult. So that's why we choose comparison method to find out all the unknown ABC. So once we find our unknown ABC, we have to rewrite it in our partial fractions. So we substitute our answer back to the fraction forms. So therefore, 8x squared over x, 2x squared plus 3 will be equal to A is 5. Then b is negative 2x plus c is 0. Okay, so negative 2x I can factorize out. So I get negative outside. Okay, then this is 2x squared plus 3. So this is how we get our partial fractions. So these partial fractions give us 6 marks. So forming the partial fraction format, it will be our basic. Then doing our equation, finding our constant A, and then we use comparison method. Okay, so we use comparison method to find out what is our B and C. So lastly, this is our partial fraction. So that will be our first part from these questions. Okay, so after we get our partial fraction, they say hence. You see the question hence means we have to use our result. This result to finding this integration. Okay, so this fraction we are going to substitute its partial fractions so that we can integrate these questions. So we are going to integrate these questions, or integrate this. So I will integrate it one by one. Integrate 5 over x dx plus, no, negative. So negative minus integrate 2x over 2x squared plus 3 dx. So this is our integration problem. Okay, so how we going to integrate this part? Okay, we can simplify first. So look at our questions here. We can factorize out our 5. So we are integrate 1 over x. And then for this, we can factorize 2. So we are integrate x over 2x squared plus 3 over dx. Then we can use our formula. Alright, so we can use our formula. Okay, so what can we do? We can see integrate fraction. When our denominator is power to 1, integrate 1 over x. Okay, integrate 1 over x. So that's why we factorize our constant 5. We factorize 5, we're going to integrate 1 over x. Answer is ln x. So this one got modulus. Okay, modulus. So another part, we can see this is our another question, fraction also. Okay, so we integrate fraction, we have to find it, we have to check it whether in this form or not. Is it fx? Is it up here, numerator is f prime x? So if yes, we can get this format, we can get this pattern, then our integration answer will be straight away give you ln to the function at the denominator. Okay, so this one obviously is in our formula. Integrate 1 over x is ln x. So now we're going to check this. Okay, we check that function. It is our pattern. Our denominator is fx, which is 2x squared plus 3. So if you want to differentiate, it's supposed to get for x. So what we have here, they are same kind. They are same type of function, which is linear function. Just this is x, this is 4x. So what we need is 4x. Okay, so here only it is x. What we can do is we can multiply in our coefficient of 4, then divide back 4. So our questions still maintain the same questions, but we have that pattern. We have that pattern for x at numerator part. Okay, so we can multiply our coefficient when we don't have. But if this is constant, this is linear, different function, then cannot. Means that formula cannot be used. Okay, so we check it. This is fx, this is f prime x. Just multiply 4, so we can get this 4x. So multiply 4, divide by 4. Okay, so this is in our pattern already. This is f prime x. This is fx. So we can do our integration. Here, integrate 1 over x, it will become ln x, so modulus. Remember to put your modulus for the function to indicate that whatever ln brings here, it should be positive. Okay, we do not make our function undefined. Okay, so make sure everything ln bring here is positive. So that's why our function here, we make it modulus, we make it positive. So this one 2 over 4 simplify become negative 1 over 2. And when we integrate fx f prime x, this gives us ln to the function 2x squared plus 3. Then after we integration, we are going to class C because this is undefined in the grade. And then we can see ln minus ln. Actually, we can simplify some more. Okay, so we can simplify some more. How we simplify these questions is we can use our properties of logarithm, where our 5 we can move up. So we can ln to the x power of 5. Okay, modulus. This one will be ln, here will be power of 1 over 2. So 1 over 2 will be square root 2x squared plus 3 modulus plus c. So when ln minus ln, our answer will be ln minus ln. We can simplify. The item will be in divide, which is x power 5 will be divided by square root of 2x squared plus 3. So this is how we simplify. ln minus ln. So we just make sure this function is positive. So that's why we maintain this symbol of modulus. Okay, so we see our marking scheme here. What is important here? Of course, when we want to integrate, we apply our partial fraction. Okay, we're not going to integrate this question. We instead of what we find here is our partial fraction. So when we want to integrate this question, we use their partial fraction form to integrate. Then, okay, then we're going to see integration. Integration 1 over x is concept of ln. Okay, ln x. So for here, integration of fx, f prime x. So showing out the pattern. Okay, so this is another part of our answer. And then we get this. We get this answer. Then finally we have to simplify. So this is 1, 2, 3, 4, 5, 6, 7. So this is our 7th marks for this part.